Students, now we are going to start combustion and flames. First, I am going to give you the set of videos so that you can understand what exactly is the chapter about. Then I am going to give you the expression part of the textbook, which will be followed with my explanation so that you can gain the knowledge in both the ways, like perfectly. Okay, so watch these videos again and again so that you understand them in the first attempt only. Thank you.
Hello friends, this video on combustion and flame part 10 is brought to you by examfear.com. No more fear from exam. So we are now going to talk about flames. So everywhere we discussed about combustion, we found that the result of combustion is either a flame or a fire. So here we are going to talk about flames and how are flames different for different combustible substances. So what exactly is a flame? So it is a hot, glowing, ignited gas during combustion. Now, whenever the process of combustion happens, that is, the combustible substance reacts with oxygen, releasing a lot of heat and light. So, how is this heat and light released? It is released in the form of a flame. Now, this flame again differs from one object to another. So, if you look at a candle, so the first thing that comes to your mind when you think of a flame is that of the flame of a candle. So if you look at the flame, how does it look? It looks somewhat yellowish to orange in color. That's how it normally looks when you see it from far. So this is the visible gaseous part. It is actually gas. So do you think that flame is a solid or a liquid? No, it is all gas. So it is the ignited gas which becomes visible during combustion. So that is called flame. Now, if you look at the flames from different objects, that is the candle flame or the LPG flame or even the Bunsen burner flame. So, all of them, they look quite different from each other. So, if you look at the Bunsen burner flame, it is more bluish in color. You look at the candle flame, it is more yellowish or orangish in color. If you look at the LPG flame, again there also your gas oven, the flame there also is little bluish in color. So the type or the structure of the flame, the color of the flame, it varies from one object to another. Now the question is, do all substances produce flames during burning? Now we know that combustion doesn't happen for all substances, but it happens for all combustible substances. Now, is it necessary that all combustible substances will produce flame when they undergo the process of combustion? Let us take two examples. The first example is that of a candle. So in case of candle, when you light the candle, when you bring a matchstick near the candle, it catches fire and you see flames. So when do you see flames? During combustion. So that means candle produce flames during burning. Now let us take another example of, say, charcoal. So what is charcoal? Charcoal is the object which is obtained by heating wood in absence of oxygen. So if you heat wood, what you get is nothing but charcoal. So charcoal also acts as a fuel. Now when you burn charcoal, what happens? Do you see flames? Now in the picture you see, it clearly shows that there is no flame as such. All you can see is a reddish glow, but there is no flame as such. So that means not all combustible substance produce flames, but in this case heat is produced, right? So heat is being produced. That means this process which is taking place here is combustion, but there are no flames. So that means not all substances produce flames during combustion. So the question is, which substances produce flames? Substances which vaporize during burning produce flames. Now what do we mean by vaporize? That means those substances which get converted into their vapors during burning, only they produce flames. Now again, let's go back to the example of the candle. So in candle, what do you think is getting vaporized when it is being burned? It is the wax. So have you ever observed when the candle is burning, the wax is actually being melting. So that means the wax is actually getting, those wax melts are actually getting converted into vapors, and due to the formation of those vapors we are able to see the flame, because flame is nothing but the ignited vapors. Vapors are only being visible as flames. But in case of charcoal, no vaporization is happening. Nothing is, no part of the substance is actually getting converted into vapors. Since there are no vapors, therefore there are no flames. So not only candle, let us take other examples also. So if you take the example of the gas burners, so there also, what is it that is getting converted into vapors? It is nothing but the LPG. The LPG gas which is stored inside the cylinders. So LPG is stored in cylinders with most of it being in liquid form and an upper layer being gaseous. So what does LPG do in order to vaporize? So LPG takes heat from the surrounding environment and naturally reverts to a gaseous state. So in order to vaporize, what we need to do in order to vaporize LPG, all that is needed is just take a matchstick or a gas lighter in front of it, and that's all. So the LPG gets vaporized, and due to the formation of these vapors we see the flames. That is why you would have observed that if your gas burner, this area, if it is wet, so if it is wet, in that case, even if you bring a matchstick near it and switch it on, but it doesn't catch fire easily. Why? Because of the presence of water. So water will lower its ignition temperature and therefore it will not allow it to catch fire. So here also something is getting vaporized, that is why we see flames. So even if you talk about the Bunsen burner, so there also you see in Bunsen burner, if you have a Bunsen burner in your chemistry lab, please have a look at it. You will see that there is a pipe which is nothing but the gas pipe. This gas pipe is connected to the Bunsen burner, and this gas gets converted into vapors, and those vapors are seen as flames. So wherever there is vaporization taking place, you will see flames, and where there is no vaporization taking place, you will not see flames. So it is not necessary that combustion is always accompanied by formation of flames. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on combustion and flame part 13 is brought to you by examfear.com. No more fear from exam. So based on whatever we have studied so far, we know that fuels release energy. And how do they release energy? By the process of combustion. Now again, we also saw that using different fuels involve different advantages and disadvantages. So we have also learned about the characteristics of good fuel and which fuel should be preferred over others. Now, when we spoke about the fossil fuels, the most commonly used fuels, that is coal, petroleum and natural gas. Now, it is also important to know that these fuels can be harmful too. So it is not only the advantages which are associated with these fuels, but they can be dangerous as well. So let us look at the disadvantages which are associated with the use of fossil fuels. Now, some of the disadvantages, the first one is that it causes severe air pollution, because when you think of fossil fuels, what are they? So the three common fossil fuels are coal, petroleum and natural gas, right? So when you burn any of these, you burn coal, a lot of smoke is produced, a lot of poisonous gases are produced, carbon monoxide is released, carbon dioxide is released, and all these create air pollution, and air pollution has serious health effects on all living organisms. So air pollution is one disadvantage associated with fossil fuels, and it is a major disadvantage. Second is it can cause acid rain. Now, these kind of oxides which are released as a result of combustion of these fossil fuels, like oxides of carbon, carbon monoxide, carbon dioxide, nitrogen oxides, sulfur dioxides. Now all these oxides are acidic in nature. So if you remember again the lesson on metals and non-metals, where I told you that oxides of non-metals, so here these are all non-metals, carbon, nitrogen, sulfur, so their oxides are all acidic in nature, right? So these acidic oxides, so where do they go? They remain in the atmosphere, and when it rains, they mix with the water droplets and the rain becomes acid rain, because the rain also becomes acidic in nature. And this acid rain again has a lot of adverse effects on monuments. They cause blackening of the marbles. They also have they also cause serious health issues in living organisms. They also adversely affect the growth and productivity of plants. So acid rain is also something which is not at all desirable. It also causes greenhouse effect. What is greenhouse effect? Greenhouse effect is that phenomenon in which the greenhouse gases, and what are the greenhouse gases? Carbon dioxide and methane. So these gases, what do? They tend to absorb more and more infrared rays, and as a result, the overall temperature of the earth increases. So greenhouse effect actually results in global warming. Now, how fossil fuels contribute to greenhouse effect? Because burning fossil fuels release these gases. So it increases the content of greenhouse gases in the atmosphere. Therefore, greenhouse effect increases, which in turn results in global warming. So overall, if you see, using fossil fuels definitely gives us a lot of energy, which can be used for various domestic and industrial purpose. But at the same time, they have severe effects or severe disadvantages associated with the environment. And if we are getting benefit by harming our environment, then there is no point, because when the environment gets polluted, it is end of the day, it is we who are going to suffer. So we should always use these fossil fuels very judiciously. We should use them only to that extent which is extremely necessary. So coal and petroleum should be used judiciously so that they are left for our future generation, and also because if we use them in excess right now, so the environmental effects will be so much that their advantages will fade away in front of their disadvantages. So some of the ways by which we can make judicial use of energy is prefer stairs over lift, because stairs would cost electricity, and electricity is generated from, for electricity we use thermal power plants, and they are dependent on energy from coal. So basically, if you are wasting electricity, you are actually wasting fossil fuels. Prefer tube lights over bulbs, again to save electricity. Prefer cycling over bus, because bus would run on diesel, or any other vehicle would run on petrol or diesel. So if you do not use them and use cycle, so you are actually saving that fuel. Prefer bus over car, because a bus can carry some 50 people and a car may carry just 1 or 2 people. So that is using a bus is more advantageous. So some simple things which you can do in your day-to-day life to save energy, which in turn will help us to reduce the usage of fossil fuels, which in turn will keep our environment neat and clean and safe for us. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on combustion and flame part 12 is brought to you by examfear.com. No more fear from exam. So now I was just telling you about the magic which often many people do, and we feel that, oh wow, he is able to do it so easily. So a brief contact with a flame doesn't burn. Yes, exactly. So please do not try this yourself, but in case if you have ever seen somebody doing like this, or if you ever come across somebody doing like this, then you should know what's happening actually. So what they do is they take their finger and they move their finger very fast through this flame. So actually their fingers move to and fro, passing through the flame. So just imagine doing that, because we feel that even if we slowly bring our finger near the flame, we feel so hot. So how can somebody actually make his or her finger pass through the flame? Now this becomes possible only when the finger is only when the movement is done really fast, because in that case the finger is not exposed to the outer hot layer for a long time. So if the skin doesn't get enough time to properly get exposed to the outer hot layer, and the inner layers are not that hot, so as a result the person doesn't get hurt. So that's one thing. So, however, when somebody does that, that becomes quite fascinating and impressive to see that the person is passing his finger through a flame and doesn't get burned. So the main trick behind this is that it needs to be done really fast. If somebody is trying to do it a little slowly, the finger will get burnt because of the exposure to the outer hot layer. And moreover, whoever does it, he tries to do it from on the lower side of the flame, because lower side would mean the inner layers which are less hot, because the outer layer is very hot, as I said. So therefore it is not possible to pass your finger from this portion, because this portion is going to be very hot. This side is also hot, this side is also hot. So therefore the finger need to be passed through the bottom of the flame. So the reason behind this is inner layer is less hot and exposure of finger to the outer hot layer is for very short duration. So the duration is so short that no harm is caused to the finger. So let us now talk about the Bunsen burner flame. So still now we spoke about the candle flame. So let's talk about Bunsen burner a little. That's because you must be using it in your laboratory for performing several experiments. So you should know a little bit about Bunsen burner. So this is a laboratory equipment used for heating purposes. It was named after Robert Bunsen, who was a German chemist, and he used it for the first time. So if you look at the structure of a Bunsen burner, the speciality is that it produces a single open gas flame. So just a single flame comes out of it. So, and that is why the entire flame, it's extremely suitable for heating thin test tubes and those kind of equipments which are generally used in the laboratory. So this burner tube, the tube which you see here, this is the burner tube, which is also called as the barrel. And you see that there is an outlet here to which is connected the gas pipe. So this pipe is nothing but it is connected to the gas source. So the main gas source, from there the pipe is connected through which the gas comes, and due to the vaporization of that gas we get this flame. So here in this part, somewhere around this part, you have a structure like this which is rotatable. So basically you can rotate this structure over the barrel. So when you rotate this structure, what you can do by rotating the structure, you can alter the temperature of the flame. So this structure is known as collar, and this is called the base. It keeps the Bunsen burner stable, because it is very important to keep it stable, so for safety purposes. So now in Bunsen burner there are three types of flames. One is safety flame, the other one is blue flame, and the third one is roaring blue flame. So safety flame is that flame which is produced at a temperature of around 300 degrees Celsius. So the color of this flame is yellow to orange in color, yellowish orange in color. And this flame is not used actually for heating anything, because the temperature here is quite low. So it cannot heat anything. This only indicates that the Bunsen burner is on. So that is the only purpose of the safety flame. That is why it is called safety flame, because it is only for the safety purpose and it cannot heat anything. The next one is the blue flame, and this is the medium flame, you can say. It is neither very high nor very low flame. So it is a medium flame, and it is the most commonly used flame, and the temperature for this flame is around 500 degrees Celsius, and yes, it can heat objects, and it is most commonly used. And the third one is the roaring blue flame, and here the temperature goes as high as about 700 degrees Celsius. So here if you look at it, the color here is blue. In fact, For medium flame also it is blue in color, but for roaring blue flame you can actually see that the entire flame becomes blue in color, and at the center you can even see a blue colored triangle. So the flame becomes so intense that you can actually see a blue triangle shaped structure at the center. And when the roaring blue flame is coming out of the burner, there it is also accompanied by a noise. So which shows that this is in the roaring blue flame stage. Now how do you get these three types of flame from the Bunsen burner? So these flames are obtained at different temperatures. So how do we alter the temperature of the burner? With the help of the collar. As I said, the collar can be rotated over the barrel. So as you rotate the collar, the temperature changes, and looking at the flame you will be able to understand which flame it is. Now, if you normally want to use it for heating purpose, it is always safe to use the blue flame, which is the medium flame. Now, other than the collar, there are also valves which are present at the base of the burner, and these valves are also used for various types of adjustment of the flame height. So that's how basically a Bunsen burner works, and these are the different flames which are seen in a Bunsen burner. So similarly, for different combustible substances you see different types of flames. So that's how the concept of flame works. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on combustion and flame part 14 is brought to you by examfear.com. No more fear from exam. So with this we have reached towards the end of this lesson. So let us quickly look at some of the questions. Question number 1. List conditions under which combustion can take place. So now, as I have mentioned before also, that there are three things which are absolutely necessary for combustion to take place. First is a fuel or a substance. You need something to burn, right? Otherwise there will be no combustion. So in this case, the paper is the combustible substance or the fuel. Air, because combustion happens in presence of oxygen. Combustion is nothing but reaction of the substance with oxygen to release lot of heat. That is combustion. And the third requirement is heat. So this heat will increase the temperature of the substance so that it can reach its ignition temperature. Ignition temperature varies for each substance, and it is that minimum temperature at which a substance catches fire. So these are the three things which are extremely necessary for combustion to happen. Question number 2. Fill in the blanks. Burning of wood and coal causes dash of air. So when we burn wood or coal, what happens? They release a lot of poisonous gases, they release a lot of smoke. So all these causes pollution of air. A liquid fuel used in homes is, so one example of a liquid fuel which is used in home, maybe to light lamps. Yes, it could be kerosene. Because normally you have other fuels like petrol, diesel, but we do not really use them at home. Fuel must be heated to its dash before it starts burning. So the minimum temperature where it starts burning, that is the ignition temperature. So any fuel has to be heated till their ignition temperature. Fire produced by oil cannot be controlled by. Now, how do we control fire? We have different ways. We can make use of water, we can make use of carbon dioxide. Now, water cannot be used to control fire in some cases. One such example is the electrical equipments. The other example is oil, because oil and water, they really do not mix with each other. Now, when they do not mix with each other, then water will not be able to reduce the overall temperature, because water controls fire by reducing the temperature of the substance. But in this case, water doesn't mix with oil, so it will not be able to reduce the temperature. So fire caused by oil will not be controlled by water. Question number 3. Explain how use of CNG in automobiles has reduced pollution in our cities. CNG is nothing but compressed natural gas. So CNG is comparatively a cleaner fuel when compared to petrol or diesel. So it is a cleaner fuel in terms of it is very efficient because it leaves very less residue when it is completely burnt. So when you completely burn the fuel, if a lot of residue is left behind, so that residue is again going to cause trouble to the environment. Right? That also proves that the fuel was not efficient enough. Most of it remained there as residue. So obviously, only a small part of the fuel was actually able to produce energy. But when there is less residue, so that means first of all, the fuel was efficient. Most of the fuel got converted into energy. Secondly, we have less waste material present for the environment. So that is also an advantage. So that means it is very much environment friendly, and it also produces less harmful gases when it is burnt. Like in case of coal, when you burn coal, a lot of smoke is produced, lot of harmful gases, which if breathed in causes a lot of problems in human beings. But here comparatively, the gases which are produced, they are also less harmful. So overall, we can say that CNG is very environment friendly, and that is why use of CNG is preferred over petrol or diesel. Question number 4. Compare LPG and wood as fuels. So here also, if you compare both of them, you will see that LPG is more environment friendly when compared to wood, because when both of them are burnt, in LPG no smoke is produced, it is very less, but in wood a lot of smoke is produced, which again is hazardous for health. In LPG, carbon monoxide is not produced, and carbon monoxide is a harmful gas. It causes environmental pollution, it results in acid rain, so it is not a good gas. But in case when you burn wood, carbon monoxide is produced. So LPG causes less air pollution because no smoke, no carbon monoxide, no harmful gases, whereas wood causes a lot of air pollution. If you compare their calorific value, you will see that LPG has a higher calorific value. Calorific value means the amount of heat energy that is produced by burning 1 kg of the fuel. So that means it produces more heat. Producing more heat is again a characteristic of a good fuel. So that way also LPG is a better fuel when compared to wood. So you can actually match their calorific values. So LPG is quite higher when compared to wood. Question number 5. Give reasons. Water is not used to control fires involving electrical equipments. Now when I say water, we normally do not mean distilled water. It is not pure water. So this water contains dissolved salts and minerals in it. So this water is a good conductor of electricity. Now since it can conduct electricity, so when we put water over electrical equipments, then chances of getting electric shock increases. Therefore, water is not used wherever electrical equipment is involved. Instead, what is used? Carbon dioxide is used. LPG is better domestic fuel than wood, again because LPG is environment friendly, less smoke is produced, less air pollution, higher calorific value. Paper by itself catches fire easily, whereas a piece of paper wrapped around an aluminium pipe does not. Now, how easily an object will catch fire, that completely depends on the ignition temperature. So those substances which have very low ignition temperature, they will catch fire very easily. So the same thing happens here. Ignition temperature of paper is very less, so it catches fire very easily. But the ignition temperature of aluminium is quite higher. So when you have the same piece of paper but it is wrapped around aluminium, so the overall ignition temperature increases. And that is why they do not catch fire that easily. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on combustion and flame part 15 is brought to you by examfear.com. No more fear from exam. Question number 6. Name the unit in which the calorific value of a fuel is expressed. So calorific value is the amount of heat energy which is produced on complete combustion of 1 kg of fuel. So heat energy, units of energy is joules. Now here we are talking about huge amounts of energy. So we use, say, kilojoules, right? So the unit in which we will measure this is kilojoules per kg. That means how much kilojoule of energy is being produced by 1 kg of the fuel. So the unit is kilojoule per kg. So if you look at the calorific values of various fuels, for example, for coal, the calorific value is around 25,000 to 33,000 kilojoules per kg. If you look at the calorific value of petrol, it is 45,000 kilojoules per kg. That means on complete combustion of 1 kg of petrol, heat energy of 45,000 kilojoules will be produced. You take example of LPG. So for LPG, it is 55,000 kilojoules per kg. So 1 kg of LPG on complete combustion will produce 55,000 kilojoules of heat energy. Biogas. This has a calorific value of 35,000 to 40,000 kilojoules per kg. Question number 7. Explain how carbon dioxide is able to control fires. Now, as I mentioned before, carbon dioxide is generally used in scenarios where water cannot be used to control fire. One such scenario is fire involving electrical equipments. So carbon dioxide is sprayed, when it is sprayed through the fire extinguishers, it acts as a blanket over the substance and the fire. So basically it cuts the contact. So this blanket is the blanket of carbon dioxide, and you have oxygen here. So basically the contact of the substance with the oxygen is lost due to the formation of blanket of carbon dioxide in between them. Now since the supply of oxygen is lost, therefore combustion does not take place, because for combustion oxygen is an important criteria. So, and why carbon dioxide forms this blanket? Because carbon dioxide is heavier than oxygen. So therefore it tends to settle down, and that's how it tends to form a layer below oxygen. So it acts as a blanket on the fire, contact with oxygen is lost, and therefore the fire gets extinguished. Question number 8. It is difficult to burn a heap of green leaves, but dry leaves catch fire easily. Explain. Now, when you talk about green leaves, they contain moisture, they contain water, and wherever we have water, what does it do? It does some cooling. So it tends to reduce the temperature. So the ignition temperature becomes difficult to be achieved because the normal temperature gets reduced. So instead of providing heat due to the presence of water, there is a cooling effect. So therefore it increases the ignition temperature, and therefore it do not catch fire easily. So when water is present there, so it becomes difficult to reach the ignition temperature. So you can say it in other words, presence of water makes it difficult to reach the ignition temperature, and if ignition temperature is not reached, it will not catch fire. But if you look at the dry leaves, they do not contain water, so it is easier for them to reach their ignition temperature. Question number 9. Which zone of a flame does a goldsmith use for melting gold and silver? Now for melting gold and silver, the goldsmith needs lot of heat, and which is the hottest layer? The outermost zone. So the outermost zone, or the luminous or the non-luminous zone, is the hottest zone and is used by goldsmith. So outermost layer or flame is used for melting gold and silver. So this is also known as the non-luminous zone, because it is the hottest layer. Question number 10. In an experiment, 4.5 kg of a fuel was completely burnt. The heat produced was measured to be 1,80,000 kilojoules. Calculate the calorific value of a fuel. So what is calorific value? It is the amount of energy that is produced on burning 1 kg of fuel. So the question says that 4.5 kg of fuel was completely burned to produce 1,80,000 kilojoules of energy. So when 1 kg of fuel will be completely burned, then how much kilojoules will be produced? 1,80,000 divided by 4.5 kilojoules per kg. So this comes out to be 40,000 kilojoules per kg. So this would be the calorific value of the fuel. Question number 11. Can the process of rusting be called combustion? Discuss. What is rusting? What happens in rusting? Rusting is the process, rusting happens in case of metals like iron or copper. So when they are exposed to moist air, they form oxides, and the formation of their oxides results in the formation of a layer over their surface. For example, in case of iron, there is a reddish colored layer. In case of copper, there is a greenish layer. But in case of rusting also, rusting is also oxidation, where the metal actually combines with oxygen to form oxides. And during that process, rust is formed. But it is not combustion. Why? Because how do we define combustion? In combustion also oxidation happens. So the similarity between rusting and combustion is that both of them are oxidation. That is, in both the processes, the substance combines with oxygen. But in case of rusting, there is no heat released. But in combustion, heat has to be released. So that is how we define combustion. Only if oxidation results in production of heat and light, that is called combustion. But in rusting, there is no heat released. So if you compare these two processes, when you burn wood, a lot of heat is released. Light is also released. So this is combustion. But if you look at the rusting of copper, so there is a formation of an additional greenish layer due to the formation of rust, but there is no heat which is released during the process. Therefore, rusting cannot be called combustion, mainly because no heat is produced during rusting. Question number 12. Abida and Ramesh were doing an experiment in which water was to be heated in a beaker. So you have a beaker with water. So Abida kept the beaker near the wick in the yellow flame, in the yellow part of the candle flame. Okay, so let us say this is Abida. So what did she do? She kept the beaker near the wick in the yellow part of candle flame. So this is the yellow part of the candle flame, and she kept the beaker in that part. Ramesh kept the beaker in the outermost part of the flame. So this was the outermost part of the flame, the bluish part. So this is what Ramesh did. So whose water will get heated in a shorter time? Now here the beaker is placed in the middle zone or the luminous zone, and here the beaker is placed in the outer zone, and we know that outer zone is the hottest zone and middle zone is less hot. Now whichever will be in the hotter zone will get heated up quickly. So that means this will get heated up in lesser time. So this will get heated in a shorter time. So with this, we have reached towards the end of this lesson, and I hope that this lesson on combustion and flames would have helped you. So please look at the concepts, focus on the understanding, and see you all in the next lesson. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again.
Combustion.
Introduction. In the Stone Age, people never knew the use of fire. They used to eat raw food. It was by accident they found that by rubbing two stones, fire can be produced. They found that cooked food tastes better. Slowly, they started using dried twigs, coal, kerosene, and then gas to make fire. These, on burning, not only produced heat but also light. Burning of a substance to give heat and light is called combustion.
Combustion. A chemical process in which a substance reacts with oxygen to give off heat is called combustion. The substance that undergoes combustion is said to be combustible. It is also called a fuel. The fuel may be solid, liquid, or gas. Sometimes light is also given off during combustion, either as a flame or as a glow. In the reactions mentioned above, magnesium and charcoal are combustible substances.
Magnesium burns to form magnesium oxide and produces heat and light. We can perform a similar activity with a piece of charcoal. Hold the piece with a pair of tongs and bring it near the flame of a candle or a Bunsen burner. What do you observe? We find that charcoal burns in air. We know that coal too burns in air, producing carbon dioxide, heat, and light. Materials of combustion. Collect some materials like straw, matchsticks, kerosene oil, paper, iron nails, stone pieces, glass, etc. Under the supervision of your teacher, try to burn each of these materials one by one. If combustion takes place, mark the material combustible, otherwise mark it non-combustible. Is a chemical reaction in which heat and light are produced. Example, heated magnesium ribbon, when introduced into a jar of oxygen, burns, producing heat and dazzling white light. 2 mg plus O2 gives 2 mg O plus heat, light. Combustible substances. When paper, cloth, or wood comes into contact with fire, it burns. They are combustible. Try to do the same with a spoon, a glass piece, or water. They do not catch fire and hence are non-combustible. Substances which burn when brought into contact with fire are called combustible substances, and those which do not burn are said to be non-combustible. Supporter of combustion. Light a candle, invert a glass tumbler over it. What happens? It burns for a little while and then is put out. The candle burns by taking the oxygen of air. Once the oxygen is over, it is put out as the remaining gases like nitrogen, carbon dioxide do not support combustion. This principle is made use of in electric bulbs which are filled with non-combustible gases like nitrogen and argon to prevent the filament from burning. It is not only oxygen which supports combustion, but oxides of nitrogen and chlorine also support combustion. Supporting combustion. Place a piece of burning wood or charcoal on an iron plate or tawa. Cover it with a glass jar or a tumbler or a transparent plastic jar. Observe what happens. Charcoal stops burning after some time. Can you think of the reason why it stops burning? As there is no air to support burning, it stops. Ignition temperature. A substance that catches fire very easily is said to have a low ignition temperature or kindling temperature. They are called inflammable materials. Cooking gas, petrol, and white phosphorus have low ignition temperatures. Materials like wood and coal have high ignition temperatures. The ignition temperature of a material is defined as the lowest temperature at which it catches fire. Temperature. Make 2 paper cups by folding a sheet of paper. Pour about 50 ml of water in one of the cups. Heat both the cups separately with a candle. What do you observe? If you continue heating the cup, we can even boil water in the paper cup. The heat supplied to the paper cup is transferred to water by conduction. So, in the presence of water, the ignition temperature of paper is not reached. Hence, it does not burn. The substances which have very low ignition temperature and can easily catch fire with a flame are called inflammable substances. Examples of inflammable substances are petrol, alcohol, liquefied petroleum gas, LPG, etc. Rapid combustion. Combustion that takes place at a very fast rate is called rapid combustion. LPG, liquefied petroleum gas, and dry grass are examples of substances which undergo rapid combustion. Sometimes a large volume of gas is liberated in combustion besides the production of heat and light. The sudden evolution of large quantities of gas creates excessive pressure that produces a loud noise. Such a combustion is known as an explosion. The bursting of crackers and the shot of a gun are examples of explosion. Slow combustion. Combustion that takes place at a slow rate with steady production of heat and light is called slow combustion. Burning of coal and rusting of iron involve slow combustion. In fact, respiration and digestion are also slow combustions. Spontaneous combustion. Oil paints, when thrown into a closed container or garage, spontaneously catch fire. The same phenomenon occurs in a haystack fire. Bacteria present in the hay cause slow oxidation of the organic material of the hay, resulting in the release of heat. When ignition temperature is reached, the hay catches fire. Combustion that occurs without the supply of external thermal energy is called spontaneous combustion. Incomplete combustion. Burn a candle. Hold a china dish over it. A deposit of soot is formed. This soot is nothing but carbon, which has not undergone combustion. Incomplete combustion takes place when camphor is burned. Incomplete combustion therefore results in formation of poisonous carbon monoxide, deposition of soot. Efficiency of the fuel is less as it does not produce the maximum amount of heat. Methods of putting out fire. Fire is a good servant but a bad master. Despite the best of care, fire sometimes breaks out in homes, schools, forests, theatres, slums, etc. Not only is there extensive destruction of property, but often many precious lives are lost in fire accidents. Thus, the methods of extinguishing fire are very important. What are the steps to be taken for putting out a fire? Break the contact of the combustible substance with the fire. Stop the supply of the supporter of combustion. Cool the burning substance below its ignition temperature. Sand and water are usually thrown on burning matter to extinguish fire. Sand covers the fire and cuts off the supply of air. Water cools the object and brings its temperature below its ignition temperature. Water also cuts off the supply of air, the supporter of combustion. Fire extinguishers. You must have seen fire extinguishers kept in schools, theatres, hospitals, business places, etc. Fire extinguishers are devices used to put off an accidental fire. They are painted red for easy identification. Let us now consider the various types of fire extinguishers that are effective for different types of fire. Sodium bicarbonate fire extinguisher. It consists of a large cone-shaped steel vessel containing a strong solution of sodium bicarbonate, NaHCO3, or solid bicarbonate. The bottom of the vessel is fitted with a metal plunger and a bottle of concentrated sulfuric acid. When in need, bang the knob or plunger at the bottom. It breaks the bottle containing the acid. The acid reacts with sodium bicarbonate solution, releasing carbon dioxide, which comes out through the nozzle and puts out the fire. Sodium bicarbonate plus sulfuric acid gives sodium sulfate plus water plus carbon dioxide. 2NaHCO3 plus H2SO4 gives Na2SO4 plus 2H2O plus 2CO2. Liquid CO2 fire extinguishers. Soda acid type. This is very effective as a household fire extinguisher. A cross-section of this fire extinguisher is shown in figure. A strong solution of sodium bicarbonate is kept in a metallic container, just above which a bottle of concentrated sulfuric acid is positioned. When the knob is struck, the acid bottle breaks, and the sodium bicarbonate solution comes into contact with the concentrated sulfuric acid. This produces CO2. 2NaHCO3 plus H2SO4 gives Na2SO4 plus 2H2O plus CO2. The carbon dioxide produced is ejected at the nozzle under pressure, together with the solution in the container. The carbon dioxide smothers the flame, whereas the water from NaHCO3 solution has a cooling effect on the burning material.
Types of combustion. Bring a burning matchstick or a gas lighter near a gas stove in the kitchen. Turn on the knob of the gas stove. What do you observe? Please try this experiment under the supervision of an adult. The type of combustion in which a material suddenly bursts into flames without the application of any apparent cause is called spontaneous combustion. We generally have fireworks on festival days. When a cracker is ignited, a sudden reaction takes place with the evolution of heat, light, and sound. A large amount of gas formed in the reaction is liberated. Such a reaction is called explosion. Explosion can also take place if pressure is applied on the cracker.
Structure of a flame. Light a candle. Hold a glass tube with a pair of tongs and introduce its one end in the dark zone of a non-flickering candle flame. Bring a lighted matchstick near the other end of the glass tube. Do you see a flame? Notice that the wax near the heated wick melts quickly. The substances which vaporize during burning give flames. For example, kerosene oil and molten wax rise through the wick and are vaporized during burning and form flames. Effects of the flame. When the candle flame is steady, introduce a clean glass plate or slide into the luminous zone of the flame of a candle. Hold it there with a pair of tongs for about 10 seconds. Then remove it. What do you observe? A circular blackish ring is formed on the glass plate or the slide. It indicates the deposition of unburnt carbon particles present in the luminous zone of the flame. Hold a thin, long copper wire just inside the flame for about 30 seconds. Notice that the portion of the copper wire just outside the flame gets red hot. It indicates that the non-luminous zone of the flame has high temperature. In fact, this part of the flame is the hottest part. Characteristics of a good fuel. It must be easily available and inexpensive. It should be easy and safe to handle. It should be convenient to store and transport. The waste products of its combustion, such as smoke, soot, and ash, should be minimum. It should produce a large amount of heat in proportion to its weight. It should have a low ignition temperature. On combustion, it should not produce toxic products. Calorific value of a fuel. The calorific value of the fuel is the amount of heat produced when 1 kg of the fuel is burnt completely in oxygen. More calorific value, better is the fuel. Types of fuels. Fuels are classified as solids, liquids, and gaseous fuels. Solid fuel, wood, coal, coke. Liquid fuel, kerosene, petrol, diesel, alcohol. Gaseous fuel, water gas, producer gas, coal gas, natural gas, LPG, biogas.
Burning of fuels leads to harmful products. The increasing fuel consumption has harmful effects on the environment. 1. Carbon fuels like wood, coal, petroleum release unburnt carbon particles. These fine particles are dangerous pollutants causing respiratory diseases such as asthma. 2. Incomplete combustion of these fuels gives carbon monoxide gas. It is a very poisonous gas. It is dangerous to burn coal in a closed room. The carbon monoxide gas produced can kill persons sleeping in that room. Combustion of most fuels releases carbon dioxide in the environment. Increased concentration of carbon dioxide in the air is believed to cause global warming. Global warming is the rise in temperature of the atmosphere of the Earth. This results, among other things, in the melting of polar glaciers, which leads to a rise in the sea level, causing floods in the coastal areas. Low-lying coastal areas may even be permanently submerged underwater. Burning of coal and diesel releases sulfur dioxide gas. It is an extremely suffocating and corrosive gas. Moreover, petrol engines give off gaseous oxides of nitrogen. Oxides of sulfur and nitrogen dissolve in rainwater and form acids. Such rain is called acid rain. It is very harmful for crops, buildings, and soil. Use of diesel and petrol. The use of diesel and petrol as fuels in automobiles is being replaced by CNG, compressed natural gas, because CNG produces the harmful products in very small amounts. CNG is a cleaner fuel.
Solid fuels. Wood, coal, coke, and paraffin wax are some important solid fuels. Wood has been a traditional fuel. Of late, however, there has been an increasing awareness that felling of trees for fuel could prove to be an environmental hazard. Coal is available in plenty in India. Coal is used directly as fuel or for the production of more valuable types of fuels such as coal gas and coke. Paraffin wax is obtained during distillation of petroleum. It contains a mixture of heavier hydrocarbons. It is used in the manufacture of candles. Combustion and light. Natural gas or marsh gas. This is formed in marshy areas. It consists of a mixture of methane and ethane. LPG, liquefied petroleum gas, the commercial fuel marketed as Indane, is a mixture of butane and propane. Mercaptans are added to the LPG to detect leaks. Gobar gas or biogas. This gas is obtained by the bacterial action on cattle dung and water in circular pits in the absence of air. Methane and ethane are the main constituents of gobar gas. This fuel is becoming increasingly popular in villages because it is inexpensive.